Again, welcome back to C++ programming language. In these lectures, we are going to study how, again, C++ programming makes a decision. In our previous lectures, we went through the relational operators, and we said that in order for most programming language, in order to make a decision, we need at least a relational operators. Relational operators can give us only one condition at a time. But in logical operators, we can combine two or more conditions. For example, we have the AND operator and OR operator. AND and OR operator is called the binary operators. So we need at least two conditions. And also NOT operator is unary. So if it's not true, then it's false. Not false is true. A unary operator means we need only one condition or one operand. So again, we are going to see an example and also go through the syntax. So we start with an example here. We declare three variables here, named X, Y, and Z, and they are all int. We assign 12 to X, 5 to Y, and -4 to Z. So now we are going to use the AND operator here. Here we say that if X is greater than Y and Y is greater than Z, if both conditions are true, then we are going to execute the statement that follows it. In this case, they are true because from here we can see that X is 12. Is 12 greater than 5? Yes. Y is 5. Z is -4. Is Y greater than Z? That is true. So in AND logical operators, if both conditions are true, then we can execute the solution and the statement that follows. Now, if one of the condition is false or both of the conditions are false, then we are going to skip the statement that follows, which means it's false. So it's only true if both conditions are true. Now, we have the second one here. We say if S is greater than Y and also Z is greater than Y, in this case, it will be false. Why? We know S greater than Y is true, but Z greater than Y, -4, is not greater than 5. So that's false. So as we said earlier, if one of the conditions is false, then the outcome will be false, which means any statement that follows it will be skipped. Now let's go to the OR operator. So in the OR operator, we say S is less than or equal to 5 or Y is equal to Z. So in this case, is X less than or equal to Z? Let's see. That's false because it's 12 less than or equal to -4. That's false. Now, is Y equal to Z? That's false also. It's 5 equal. So the output will be false. But the next one we have S is less than or equal to Z, which is false, or Y not equal to. So Y is not equal to Z, which is true, because 5 is not equal to -4. But since one of the conditions is true, the output will be true. If both conditions are true also, the output will be true. So again, with the AND operator, the only time is true if both conditions are true. If both conditions are false, it's false. If one of them are false, it's false. And the OR operator, the only time the condition is false is if both of them are false. So if both of them are true, the output will be true. If one of them is true, the output will be true. Then negation, as we said, is a unary operator. It needs only one condition. So here we have, is S greater than or equal to Z? Yes, 12 is greater than -4. So it's true. But we say not true. So if it's true, not true will be false. And if it's false, not false will be true. So again, it's more or less saying negation or complement. So let's see example now in the coding. So this is the syntax for C++. We use the, as we said, the %2 is for the N, and this is quality, and then the 2 is for the OR. So now we are going to determine the user's loan qualification. The question here said, if employee is equal to Y, which means if the person is employed is yes, and also is a recent graduate, which is yes, then we say that you qualify for the special interest rate. Now we are using AND operator. So this means the person must be employed, must be Y, and also the recent grade must also be Y in order to execute the statement here. If one of the condition is not Y or both of them is not Y, then we are going to execute the else section. I think we discussed this in the previous lectures, how to use the if-else statement, two-way statement. If a condition is true, whatever follow the ifs will be executed. If the condition is false, then we go to the else section to execute it. Now, let's see another example here. So we're going to determine the user's loan qualification. This time we say that if the income is greater than or equal to mean income, or the years is greater than mean years, then you qualify. Now here we are using or operator. So only one of the conditions must be true, or both of the conditions can be true, then we are going to print out the statement you qualify. If both conditions are false, then we are going to print the else section. Next, we have determined the user's loan qualification. Now we are using not here. So first, when you have most programming language, anytime we have, let's say, a nested loop or a nested if statement, the outer statement condition will be tested first before the inner. By here, in this case, using logical operators, we have to test the inner first. So for example, here we say income is greater than or equal to mean income, or years is greater than mean years. If the condition here is true, then we are going to negate it. So if it's true, not true will be false. But if the condition here is false, then the negation or the not operator will make it true. So if it's true, not operator make it false. If it's false, not operator make it true. So the only way the CR statement here will execute is if our condition is false and we say not false is true, then we print out the statement that follows. Now, if the condition is true and not operator will make it false, then we are going to print the else section. So the logical operators, we have some notes here. Always the highest precedency is the not operator, then followed by the and operator, then the or. So again, the logical operators have is precedency, always not first, and or. If they are all in the same, here we didn't do not first because we can see there's a parenthesis here. So we did the inner condition in the parenthesis first. So the parenthesis changes, same like arithmetic operations. Parentheses can change the order of the precedency. So we did parenthesis first with or, then we check the not. But if everything is in one parenthesis, then the not will be again executed first, then and if we have, then or. So now here we say that if the value of an expression can be determined by evaluating just the sub-expression on the left side of a logical operators, then the sub-expression on the right side would not be evaluated. This is called a short circuit evaluation. So normally, if we are using logical operators and or in a condition, and we are designing our if statement, we always should put, if it's n, we always should put the condition that most likely will be false. Because, for example, if I have 100 conditions and the first condition is false and all of them is n operator, if the first condition is false, then the rest will be false. Even if the rest are true, the outcome still will be false. So this is the idea of short circuit evaluation. If I'm using n operator, I'll put the first condition that is likely to be false. Because if the first condition is false, the rest doesn't matter. It can be true or false. The outcome is still false. Now, in terms of the or, we're always going to put the condition that is true, because we know that in or, if one condition is true, then it doesn't matter. The rest can be true or false. The outcome is true. So that is the concept again of short circuit evaluation. So here we have example to check numeric ranges with logical operators. Here we say we're going to use this to test to see if a value falls inside a range. So for example, if a grade is greater than or equal to 0 and the grade is less than or equal to 100, then we say the CR valid grade. So normally, let's say this is a exam score. We know exam scores should always be between 0 to 100. So this is valid. Now here also we say can also test to see if the values falls outside of the range. So here we say that if grade is less than or equal to 0 and greater than or equal to 0, we can say it's invalid grade. Normally we should say if the grade is less than 0 and is greater than 100, because here we know 100 also is A. A student can get 0 in a test. Now here we say we cannot use mathematical notation here. We cannot do it in C++, we can't do this here. We have the grade that we say is less than or equal to 100 or greater than or equal to 0. No, this is like a college algebra concept. It doesn't work in C++ programming language. So in C++, we must have each variable with its value range. So grade is less than or equal to 0 or grade is greater than or equal to 0. We use the logical operator. Here we don't have the logical operators. So you can't have two conditions without the logical operators in C++. So next we can also use it to test or to validate user input, to test if a user input is good or not. So input validation, we inspect the input data to determine whether it is acceptable. If it's a whole number, so may say, okay, if the value is within the range or it's not. Or if a user is supposed to enter a value, but he enter a character, we can also check and see. Because we know bad output will be produced if we have bad input. So we can perform the various tests, as we said, the range, or reasonableness, or valid menu choice, or divide by 0. We know anytime, even if we use our calculator and we divide the value by 0, we get an error message. There's no correct answer. The only correct answer is if you divide 0 by a number, the answer is 0. Also, menu, maybe we may have a program saying that if you choose 1, if you have a job, if you don't have a job, choose 2, etc. We can use also. So this is an example of input validation in a program. So here we have a test score. We declare variable name test score. And we ask the user to enter the test score. Enter your numeric test score, and I will tell you the letter grade you earn. So seeing the user enter the test score. So now we are going to check if the test score is greater than or equal to mean score, and the test score is less than or equal to the mass score. This is, we check to see if the input is valid. So let's say the mean score will be 0 and the mass score will be 100. So it should be between 0 to 100. Now we are going to determine the letter grade. So if the test score is greater than or equal to A score, we'll say that your grade is A, so your grade is B, greater than or equal to B score, your grade greater than, we also have C, your grade is C, then greater than or equal to D score, then your grade is D, else you fail. So we have option for A, B, C, D. Now, the good thing with if and else if is that if the first condition is true, then we are going to skip the rest. So let's say, for example, we said that A score is 90 to 100, and B score is 80 to 89. Now, if a user enter 90, 90 is greater than the A score, it will print. And if 90 is greater than A score, the same 90 also is greater than the B score. But if we use if throughout, then it's going to test all the conditions. If the first condition is true, it's going to test the second condition, etc. By using if, and else, when a condition is true, it will come out of the if condition. So it will not test the rest of the condition. Also, another option is that if all the conditions are false, then the else section is default. It always will say your grade is F. Otherwise, if the range of the value that the user enter is not in this range, let's say between 0 to 100, then we are going to, we are not going to print anything in the if statement. Rather, we go outside and we are going to print this is the else section, as we said earlier, is always the false section. Then we say that is invalid score, run the program again. Also, we can compare characters. And comparing the characters, we use what we call the ASCII coding system, numeric coding system. So for example, in actual computer, A is not A. A is rather represents 65 and B represents 66. And also, for example, 1 represents 49. So if we are using relation operators to compare characters or numbers, normally we use the ASCII value to compare. Now here you can see that the 1 is in a single quote. So the 1 is not a value, more or less like a character. So here we say lowercase letters have a higher ASCII code than uppercase letters. So normally lowercase a is greater than uppercase z. So this is an example here. So here we ask the user to enter a digit or a letter. So we use the scene.getIn to enter the character. Now, we are going to determine what the user entered. So first we say that if the character the user entered is greater than or equal to 0, again, you can see that this 0 is in a single quote, so it's a character. And also CH is less than or equal to 9. Then we say you enter a digit. Else if it's between uppercase A to uppercase Z, so these two have to be true, then we say you enter uppercase. Or if it's lowercase a to lowercase z, then we're going to say you enter lowercase. Otherwise, you did not enter a digit and also you did not enter a letter. So like characters, we can also, strings also can be used comparing using their ASCII values. So for example, we have 2 strings here, name 1 and name 2. We assign Mary and Mark. The characters in each string must match before they are equal. So this means if we are checking a string, if they are the same or not the same, we check character by character. So for example, MMAARYK, so they are not the same. So now first we say it's name 1 greater than or greater than name 2. Yes, it's true. Why? Because lowercase y, lowercase k comes before lowercase y in the ASCII number system. So y is greater than k. Next, we say that, okay, is name 1 less than or equal to name 2? No. Name 1 is greater than name 2, so that is false. Then is name 1 not equal to name 2? Yes, it's true. Name 1 is Mary, name 2 is Mark. They are not the same. Then also here we can say is name 1 less than Mary J. Yes, that's true. Okay, so the next is the relation operators comparing strings in a program. So here, for example, we have a short code here. We're going to determine and display the correct price. So we say if part norm is equal to x-29a. So this is in double quotation. So as we said in C++, a character always is in a single quotation. A character can be a digit, can be a symbol. As far as it's a single quotation, it's only one character or one symbol. Now, a string always will be in double quotation. So here we have we're trying to compare part number is equal to this. If it's equal to this, then the price is, it will give us the price. Else, if part number is S-29B, then it will give me this price. Else, part is not valid part number. So also we can use the conditional operator. Normally we also use the term conditional operator is also called a ternary operator. It works the same way as if-else statement, but the format look like we have three parts. So that's why we call it ternary operator. Normally the expression section will be your condition. Then after the question mark, if the condition is true, after the question mark, condition will execute. After the question mark, the statement or expression after the question mark will execute if the condition is true. Now, if the condition is false, then the last statement, which is after the colon, will execute. So let's see, we have an example here. Here we say if S is less than 20, then we assign 10 to Y. Else we assign 20 to Z. So this means if S is less than 20, if this condition is true, then we are going to assign 10 to Y. That's it. Because the Z section is the else, which is the false section. If the condition is false, then we are going to assign 20 to Z and we leave Y alone. So here we say the first expression to be tested. That will be the condition. Second expression execute if the first expression is true. That's if the condition is true. Third expression execute if the first expression is false. So with the conditional operator here, we say the value of a conditional expression is the value of the second expression if the first expression is true. So again, the value of the second expression if the first expression, which is if the condition is true, the second expression will execute. Now, the value of the third expression if the first condition is false. So as we said, if S is less than 0 is false, then the third expression, 20 assigned to Z, will execute. If the X is less than 0 is true, then the second expression, Y equal to 10, will execute. So this is an example also for conditional operators. So as usual, again here, we include the IO stream. We also include the IO manip. And in this case, we are going to manipulate the output. And using namespace SD, we have our main function. We declare constant variable. We assign 50 to it, as we said earlier lectures. Anytime we declare constant variable, we need to initialize it. So we have a second constant variable named mean hours. We initialize it to 5. Then we have two variables, hours and charges. So the first thing we did here is to get the hours work. So how many hours will work? That's our instruction. And the employee work. We enter the hours to a variable named hours. Now we are going to determine the hours to charge for. So now we are saying that if hours, we assign the hours to hours. And here we have a condition that if it's now this is what make the difference between if-else. Here we can use if-else statement, but when you use if-else statement, it's difficult to assign the condition, whether it's true or false, to a variable. So here you can see we have our ternary operator. Our first condition is hours less than mean hours. If it's less than mean hours, then we are going to assign mean hours to the variable mean hours. If it's not less than, the condition hours is not less than mean hours, then we assign hours to it. So next we are going, so this is the ternary, this is one of the main reasons we use this ternary operator. We can test a condition and we can put the result in, or we can assign the result to a variable. Next, we calculate and display the charges. So the charges will be pay rate times hours. And we format the output with 2 decimal places, set precision, in $sign. So that will be the conclusion of these lectures. Again, if you have any question, you can send an email. Thank you.